Hey guys, this is Atul from team K21 Academy, and in this video, I'm going to talk everything about containers and Kubernetes, and I'm going to keep it high level so that a bird's view, which so that you understand these concepts, and then I'll tell you how can you go deeper into each topics that I'm covering. So I'm going to break down, possibly depending on how much each topic takes, I might break it down into different parts. So I'm thinking right now that I'm going to break down into four parts. In first part, I'm going to cover everything about in terms of a high level containers, Kubernetes, overview, hypervisors, virtual machines, differences between them, what is a microservices, what the container runtime. So I'm going to keep it high level, very high level on this particular part. Then on part two, we are going to go and look at containers and Docker. Things like Docker, its components, architecture, how do you install Docker container, the different options, different things that you need to know in terms of Docker. And then part three, I'm going to keep it on Kubernetes. What a Kubernetes mean? How does the architecture look like? Again, I'm going to keep it high level so that this session is going to be in a bird's eye view so that someone who is from a management background, someone who is from a technical architecture background, someone who's new can understand these concepts. And then how do you go deeper? We'll talk about that as well. Then fourth and final part is going to be on con containers and Kubernetes on cloud, which is basically all the four clouds, AWS, Azure, Google, and Oracle. So this is the four. I might merge them into one single training depending on how long this each of these takes. But let's go and begin with the first and most important is the containers and Kubernetes overview, what these are and how it all begin. And you might have some of these things you might have heard, but I want to repeat, but I'll keep it short and quick to the point so that you understand these concepts. So if you look at the development and evolution of development and deployment, the era in which we are looking or living right now, the development process is DevOps, which means everything is going to be in a DevOps where development and operations team working together as one single team with different tools and technologies and so that they work collaboratively, they work in a better efficient manner. Application architecture is more now done using microservices. What these microservices are, how they're compared to monolithic, we'll see it in a minute. And then the packaging and deployment of these applications is done using something called as containers. And the world we are, and then this application infrastructure which hosts these containers, microservices applications are done using different clouds, AWS, Azure, Google, Oracle. So, if we look at from a deployment point of view, we have come very far in terms of traditionally, we used to have a hardware on which we were running an operating system, which could be Solaris, it could be HP Unix, it could be Red Hat Linux or Windows and so on. And on top of that operating system, we were deploying the dependent libraries like Java or PHP or Python or anything that your application needs, like for databases, database connectivity, etc. And on top of that, we used to run application. That is how the traditional deployment used to happen. Then came, I think in 2000 era came virtualization, where you have a hardware and operating system, and depending on there are two type of hypervisors, which we'll see that in a minute. But you have an operating system. On top of that, you can run a hypervisor, which will give you an ability to run multiple machines in the form of a we call virtualized machines, so that they have their own separate operating system. And then used to run the libraries, binaries, and application on top of that. The advantage with that happened was that within one hardware, you can run different operating system, but also you can squeeze in a lot more applications with clear demarcations between those applications. So that's virtualized environment. Then came 2013-14 Docker that revolutionized the way we run containers. Oh, sorry, yeah, containers. Containers have been running for long, but Docker made it very simple and easy, where you have a container deployment, which is a model where which you have a hardware. On top of that, you have an operating system, and then on top of that, you run a container like Docker that will help you to run multiple small applications running across microservices, so they can run independent to each other with a little bit of clear demarcation, not as hard as operating system or VMs, but a better in terms of processes with their own dependencies. So you can pick a container and can run anywhere in any container runtime like Docker or Container D and Rocket, and we'll see that in a minute. What are the different container runtime? Now, this was all good, and this was a Docker, but that created a bigger problem that once you have an actual implementation, assume these are different machines, these boxes here you see here on the right-hand side of the screen. Uh, these machines run multiple containers. On one machine, you can run 5, 10, 15, 20 containers, and managing these containers, making sure that they talk to each other became very complex. Making sure that they can start and stop, and if they terminate, they can start automatically. All those things become complicated, and that is where Kubernetes came into picture, or container orchestration came into picture, which is Kubernetes. And there are multiple, we'll see that in a minute. So this is a 30,000 foot view difference between how these deployments have evolved over a period of time. Now, one question I came when I talk about this, people say that, hey, what is a hypervisor, or what are the different type of hypervisor? You might get an interviews, or you might be asking. So hypervisor, there are two type of hypervisor. Think of it as a platform or an engine, not platform, but an engine or some software that will give you an facility so that you can run multiple operating system on the same hardware. Now, these are two type of hypervisor. There's a type 1 and type 2 hypervisor. Type 1 hypervisor, where we say bare metal, you don't need an operating system. You simply put a hardware. On top of that, you put a hypervisor. And on top of that, you put the operating system, which could be different virtual machines. Whereas type 2 hypervisor, which we call hosted architecture, you have a hardware. On top of that, you put an operating system. That operating system could be HP, Unix, Linux, whatever, or Solaris, Windows, or any flavor of Linux that a hypervisor supports. On top of that operating system, you put a hypervisor, and then you run multiple machines. These are the two flavors. So hypervisor let you run a virtualized environment. That's a hypervisor. Now, another question we get is, hey, what is a virtual machine and what is containers? I'm going to keep it high level. As you go, I'll tell you how you can go deeper into these. But as I said, you have, from a virtual machines point of view, you have the underlying um, hardware, which could be a um, which could be your like your CPU, memory, processing unit, computer. On top of that, operating system, and then top of that, you have a hypervisor. That hypervisor is giving you an ability to run multiple machines. So you have a operating system here, another operating system here, third, fourth, whatever number of operating system you can accommodate, you do that. And on top of that, you have a binaries, libraries, and applications. In containers, you also have one more in between, which is called as containerized platform. You have an operating system. On top of that, instead of running directly a virtual machine, on top of virtual machine, you put one more thing, which is containerized platform, which is like containers. On top of that, then containers, you run a spaceful small image, and later we'll see how do you run those containers independently. But they are sharing the same operating system. If you're running a virtual machine on top, or a bare metal machine with the operating system, on top of that you put a containerized platform. All the containers which will run, so this will be container 1, container 2, and so on. They will have its own binaries, libraries, dependencies. As I said, Python, let's suppose it's a Python application. The Python code that you need will be all bundled within that container and can run independently anywhere on a containerized platform. So that is what is containers. So if you look at the container, you have a computer, you have a computers or a virtual machine or a machine's operating system on its own. And on top of that, you are installing a container, which is like a Docker. So this whole machine itself has its own memory, its CPU, its disk, it's an IP address and a host name that you get within a machine. But then it also have a, if you look at, then on top of that containers, you run a container runtime. This container runtime will be having its own disk, its own IP address, its own host names you will be getting within this container, and so on. So these basically they'll be so that this application app 1 is running independent to app 2, and then you can pick this container and run any other machine that has the same Docker. So it's kind of a similar to operating system, but not exactly operating system, because it's similar to VM, but it's not actually VM, because in VM you also get its own operating system, whereas in container you have a base version of operating system, which we'll see in form of images. So what is the advantage? It looks similar to VM, the container. So why I'm using, what are the advantages of containers, the virtual machine? What are the advantage of the containers over virtual machine? So advantage is, if you look at the virtual machine, takes a within the same hardware, which means with the same CPU and memory and disk space. I'll leave disk space separately because disk is pretty much more or less same, I would say. But under the same hardware, which is CPU and memory, you can squeeze in a lot more containers, because they will they will be using a very little memory and CPU, and you can restrict all the CPU and memory based on the containers. So you can squeeze in a lot more containers on um, 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 if you're running a containerized application on a hardware. Second is, if you look at the operating system or the actual application, that takes a lot less space because you're not using, or you don't install a lot more things that you do on a virtual machine. Um, so let's suppose you have two applications, you're going to put them into two different VMs, versus within a container, you will need a lot less underlying dependencies and so on containers. Similarly, the boot time, if a container fails, it takes milliseconds to start, whereas virtual machine might take a couple of seconds or a minute or so to start a boot time. So these are some of the advantages. As you see, Docker started, or containers started becoming more and more famous. Now, some of you guys might be thinking, oh, another concept I said is that containers, or you run microservices on top of containers. So the another question comes is, hey, what is the difference between monolithic versus microservices? Again, I'm going to keep it high level, as name suggests, monolithic versus microservices. But how you can go deeper, I'll tell you inside that, like where you can get hold of a little bit more. I think possibly I'll talk about in that part two on containers and Kubernetes. But if you want to go deeper version of the same, you can. But just to give you a example on here, what is the monolithic application? If you look at left hand side, here is a application, which is your left hand side is a monolithic application, which is a passenger app. Think of it as a Uber app you might be using to travel. Um, that has everything bundled into one single part. We call the like, for example, passenger management, billing, trip management, driver payment, etc. And then they connect through different interfaces of this monolithic application. The problem with this monolithic application is that, hey, if I have to scale this application, this is quite heavy and big and bulky. I need to scale. If this application needs 10, um, for example, 1 gig of memory, in order to run multiple copies, I need 1 gig each on every copy. Moreover, if I have to modify something here on, for example, passenger management, I have to take this whole application down. If there's some problem in one part, entire application will have a problem. Whereas what I do instead of that, I break down this application into smaller parts, separate tasks for management, passenger management, separate tasks for billing, separate application for trip management, and they talk to each other through REST APIs or connect with each other separately. So now, if a load increases on passenger web UI, which is quite common, I will only scale the passenger web UI automatically using a containerized application like Kubernetes. So you'll see that in a minute, um, when I go on later part. So that is a microservices one versus monolithic. Of course, I'm giving it a high level, very bird's eye view. Scaling up becomes easy, deployment becomes easy, and a lot of advantage of running these microservices. So if you look at Uber, if you look at Netflix, if you look at Gmail, a lot of these applications are written in a microservices model, bundled and then running on top of containers. That's what you see. So that's microservices. Now, these microservices, what happens? That microservices, each one separate microservice run in a container, and you can run, for example, microservices one, I can run it 10 copies of this in 10 containers here. Similarly, microservice two, it might be my passenger UI, this might be my billing, this might be my, for example, I'm checking my travel time, so that within an app, and I can run 10 copies of this container. 20 copies of this microservices, 30 copies of this microservices container, and so on. And they are front-ended by some front-end UI itself running multiple copies. So this is how these microservices and containers run in. This is another example. I could have run the same microservice on a bare metal, but then um, if my this bare metal goes down, the entire microservice, all the microservices running on this bare metal has a problem. So what I do is I run multiple copies of bare metal. Oh, just instead of just problem with the bare metal, I can't squeeze. It will be underutilizing my bare metal on if I run these microservices like that. I could have run on a virtualize, same problem. Now I'm running on containers, and you see that I can run and play, restart, manage them independently on containers. So these containers will sit on top of a virtualized, these containers will sit on top of a virtualized environment or bare metal, but with clear demarcation. Now we'll see more of these later when we look at different architectures. Now, so you might be wondering, what is this containers which I'm talking about? If I'm talking about these containers, what are the different flavors? Because container, I'm going to use word interchangeably with the Docker because that's one they started or revolutionized the way. But since then, since 2013, a lot more new containers have container runtime have done come. So Docker 2013, 14, then came Rocket, then came other open source containers, Container D, Cloud Foundry, Rocket, CRIO, Container D, and so on. So later, um, in the Kubernetes part, we'll see how um, the open source Kubernetes CNCF is adding more and more container D and other things, but you still need to learn Docker because Docker, when you build containers, Docker has a very rich and easy interface. So that's basically these are different container runtime options. When you're running container, you can run and play with minor changes. Um, you can migrate your containers from a Docker to container D or so on. Now, that came, as I said earlier, the challenge with container orchestration tool. So what is this container orchestration tool is, or why we need this container orchestration tool? So the most common question people get is what exactly orchestration means. So the orchestration comes from the word of orchestra, where if you see there's a one person who is controlling different team members playing different instruments. Someone might be on a drum, someone might be on a violin, someone might be guitar, different instruments, and one person managing and playing that orchestra. On the similar manner, you have a container orchestration tool um, and there are few of them. We'll explain that in a minute, but they manage and maintain the multiple containers running across different machines. So if you see there's a virtual machine or physical machine, this one, two, three, four, five, each of different machines here that you see here. Now, each machine can run multiple containers and managing them containers so that they can talk to each other in terms of networking, in terms of storage, in terms of connectivity, in terms of making sure if a container fails to restart it automatically and so on. That is where the container orchestration tool comes. So the role of container orchestration tool is, for example, provisioning a particular host, starting the containers, initializing the containers, making sure if a container fails to restart them, making sure that they are working as expected, exposing something called as services we'll learn and understand later part in when we go to Kubernetes, and then scaling out if a load increases, scaling out, scaling down, scaling up, etc., adding and removing containers. All these is done using container orchestration tool. As I said, there are few of them. There is a um, Kubernetes, which is quite famous. You have Apache Mesos from Apache open source Apache Mesos. You also have Docker Swarm and so on. So what are the different? If you look at the market share point of view, this is I think probably I'm picking a slide of 2020 or 2021, but the number is going to be on a higher side for Kubernetes as well. So the Kubernetes is a open source container orchestration tool, which was done by Google. They are the quite a leader. Then you have OpenShift. Then you have OpenShift is from Red Hat, IBM, Red Hat. And then you have Docker Swarm, you have Mesos, Apache Mesos, Rancher is another one, and then you have Amazon ECS, you have a lot of other things as other providers as well. So what exactly is Kubernetes is? So Kubernetes is an open source container orchestration system, as I was saying earlier, which used to automate the application deployment, scaling of scaling up, and management of these containers which are running on top of which are hosting applications. It was originally developed by and designed and developed by Google and then donated to the open source community, which is now managed by CNCF Cloud Native Computing Foundation. Now, there's another version which is called as Google Kubernetes Engine, GKE, which we'll talk later in I think in the fourth part of this series. Um, in that, we'll see which is a managed Kubernetes, which is still owned by Google, which is slightly different, but we'll understand the differences a later part. Similarly, OpenShift. OpenShift is a platform from Red Hat. This is number two, which runs containerized applications, as well as it can also do manage your virtual machine workload as well. Under the hood, it's same OpenShift, but powered by open source Kubernetes engine that you see. So what Red Hat did was they picked up the Kubernetes, put their own packaging, added some more things like CI/CD, like Ansible, Jenkins toolkit within that. It also They also provide a more personalized support, and in case you hit any problems, etc. So think of it as a I took an open source and built and my own flavor. So this is from Red Hat, or which is now acquired by IBM. So that's where we see that. Now, on top of that, you also see the managed Kubernetes, which means there is a two component in Kubernetes. We'll see that later. There's a master node, or we call control plane, and a worker node, which is called where that app data plane where applications run. And the master node or the control plane is managed by the cloud vendor, and they provide a lot of other services that a Kubernetes engine needs, like your virtual machines, underlying compute, which is virtual machines, or could be a serverless as well. They also need networking, they need storage, they need load balancers, all those things these cloud provider provides, and they run a managed Kubernetes, which we'll see. So on AWS, you have Amazon EKS. EKS stands for Elastic Kubernetes Service. Similarly, you have AKS, which is Azure Kubernetes Service, AKS from Microsoft Azure. You have Oracle, which is Oracle Kubernetes Engine, and then you have from Google, Google Kubernetes Engine, then from IBM, and so on. Now, this one question keep there's also OpenShift, which is a managed OpenShift on Azure and AWS and so on. But we'll talk about, I don't want to confuse you right now, I don't keep it a high level. Now, other thing that you get is you get a job with Kubernetes. You get a lot of CI/CD tools, and how you can learn the CI/CD. I will talk about that as well as we move forward in this program or in this course that you see. So a lot of CI/CD, which is a continuous integration, continuous delivery, deployment with using Kubernetes and deployment. So what that actually means, I'm going to give you a 30,000 high level view about what these DevOps look like. How does it look like? And if you've seen this, if you're already familiar, you can fast forward or listen and do a quick recap on this, what is actually happens end to end. So you have on one point, before even developer, there is a business users, business analyst. What they do is they talk to the customer or client end users and try to gather the requirement. And then there's requirement designer or architect will design some microservices, or how that application is being developed, needs to be developed, and then those requirements will be given to a developer. Now, I've not covered it to avoid any complications and want to keep it simple. Let's suppose your developer gets all the requirements. Now, developer will use a developer tool like Visual Studio Code or a NetBeans or Eclipse or different we call integrated development environment IDE. They will then write the code and push that code into a code repository like AWS code commit from AWS side, or from Azure you have Azure repo. You have a Google, you have a Git, which is a open source, and a Git repo, and there's a lot of other code repository tools. So each developer will develop their code and put it into a code repository. Then later part we'll see what is a Docker file, but using that Docker file through code, um, a build engineer will pick up that file or these codes and then pick up them and build using a Docker, something called as Docker image. What is Docker image? When we come to the Docker site or container image, we'll see that what that is here. So it's being built, and then it'll be a deployable unit. And if you're coming from an application administrator or application background, You might have heard of var file, which is a web archive, or enterprise archive, or Java archive, jar files, so that you can pick up the code, or .NET developer. You pick the .NET code or that particular code and run on application, underlying application server. Similar to that, you take the Docker image and then store the Docker image into another repository called image repository. And that image repository is from a Docker, you have a Docker hub. From a Azure Container Registry, you have the from a Microsoft Azure, they have this implementation of registry for storing those images, Azure Container Registry. You have Google Container Registry or AWS ECR, which is Elastic Container Registry. So someone, a build engineer, has picked up the code and stored them into a image repository here. Then on other side, your operations guys, admin guy, and all these guys are part of a same DevOps team. They are building the infrastructure, which is a Kubernetes cluster, and there are different tools available. You use kubeadm. Later, I'll tell you how you can use this kubeadm to create a 3-node Kubernetes cluster, or they can use a command line, shell command line, or they can use Terraform, which is the infrastructure as a code to automate and build that, deploy that application here. Then using various tools, any one of the tools, they create a Kubernetes cluster that could be in on-premise in its own hardware, or it could be on cloud like AWS, Azure, Google, and etc. So a Kubernetes cluster being done and built by ops guys, admin guys, and then your ops and admin guy will pick up this image and deploy that image into or create a containers, which we call pod, using this YAML file. So this is a manual method of building, are doing this in DevOps lifecycle. Now, same thing, instead of doing it manually, you can use some CI/CD tools like Jenkins or Azure DevOps or AWS DevOps and so on, and push that image into the container image repository, which will then go to the similarly. So this is CI, which is continuous integration. They're integrating and building the deployable unit. Now my CD, continuous uh, delivery, is picking that code or image and then deploying these applications on a Kubernetes cluster. So that is an entire automated CI/CD later. Now, inside the program, you will be seeing in our Docker and Kubernetes job-oriented program, you will have a dedicated module and where you're using CI/CD tools like Jenkins to deploy this code end-to-end so that you understand how the CI/CD works. So make sure that you go and attend this DevOps. The numbering or names might be slightly different, or instead of bonus, it might be something else, but then it's DevOps CI/CD using Git and Jenkins, and we're going to deploy it on Azure Kubernetes Service. So make sure that you understand AKS and how you get hold of, how you understand AKS. We'll talk about that as well. So that's something which is coming for you inside the program as well. With that, you'll be having a step-by-step video and guide. So you will first doing um, basic, very high level DevOps I've given you. Then what is a Jenkins and CI/CD look like? How do you manually and implementation wise do? And then automating the CI/CD Jenkins. So this is a whole probably around detailed step, like how do you do it manually? You'll be using deployment CLI. You'll be using command line. You'll be using some GUI. You'll be using end-to-end Azure Kubernetes Service. So make sure that you understand and you complete this hands-on lab. That will give you a full idea. Later, I'm going to tell you, first we need to understand these building blocks, just to give you a hint that that's there for you to come and consume this part, please. Now, later, so by the way, now before, as I said, now why you need to learn, and the important is probably that there are all these which are mentioned about Kubernetes. There are thousands and thousands of customers using, right from a Google to Shopify to every customer that you see will be using. So just to let you know that there'll be lots and lots of jobs around the other side. All the telecoms, all the big financial institutes, all the lots and lots of day-to-day operations are done, and applications run on top of containers and Kubernetes. And these are some of the customers that you see are using these containers and Kubernetes. And that also has resulted thousands of jobs. That's why I'm assuming you're here to make sure that you learn and understand these concepts. Same is the job opportunities, and these job opportunities are paying very good. If you look at from US, that's pretty much in the range of 200,000 and plus as well. This is I'm talking about is, if you know deeper, which we are going to cover everything here, you should be earning a lot more money. Same thing is with if you're coming from Europe, 100,000 is quite common. And then same thing from if you're from India, Asia, you have plenty of lot of money in this with this particular Docker and Kubernetes. So I hope that will entice you, that will excite you, but you have to learn and understand them better. With that, we're going to move on to the next part, second part, which is Docker or containers. And I'm going to use word Docker and containers interchangeably. If you've come so far, give me a thumbs up and let me know that you've come here, put it to WhatsApp group, go back and watch this one more time, make your notes and understand them things what you have learned so far. It might be short, quick. Put it in the LinkedIn, tag it with K21 Academy or myself, and then I want to see what you've learned on. Keep it high level bullet points on what you've learned. Did you find it useful? I said I'm going to keep it 30,000 foot view, covering things like what is the bare metal virtual machine containers and Kubernetes, hypervisor virtual machines, containers, the virtual machine difference between Docker and containers, monolithic microservices, container runtime, and so on. So I'm going to also share some notes with this, but I want to see your notes as well. So let me know if you need any help, leave that as well. And in the second part, we're going to talk and look at containers. What a container, and when I say Docker, I'm going to use word interchangeably, but more or less concept remains same. If you understand one container, picking up second container is easy. I'm going to pick Docker because it's quite famous and quite useful. On that, Docker, what are the different components, terminologies, how it works, and so on. So with that, I'm going to see you in the second part, which is phase. Let's on containers and yeah, Docker and containers, please.